All right, we're starting with number 9 for this particular video. And number 9 says, a store is implementing a 5% increase on all of their prices. A store is implementing something, like they're starting something. They're either beginning or starting a 5% increase on all of their prices. Write both the decimal and the fraction equivalent to the increase. Okay, so I'm going to remind you, remember over here, 55 over 100 was 55%. 230 over 100 was 230%. So 5 over 100 is 5%, okay? So it says write both the decimal and the fraction equivalent. Okay, so here's a fraction, but it is not in lowest terms. So I am going to look, I can do it one of two ways. I can either say, hey, let's do 100 into 5, which is going to be like, bleh. 100 won't go into 5, okay? Bring down a 0. 100 won't go into 50 either, so another 0, okay? 0 times 100 is 0. You get 50 left over, you bring down another 0. 100 will go into 500, and you get 5, okay? If you don't love long division, then I'm hoping that you remember that when you take a percent and you're going to take the little percent sign off and change it to a decimal, you take the decimal and you move it 2 times to the left, okay? So I take the percent sign off, move, here's my decimal, fill in a 0, okay? So our decimal equivalent is 0.05, okay? I can either just take the percent sign off and move, or if I don't remember how to do that, I can just do long division, but that's not super fun either, especially if you're not great at keeping up with your zeros. Okay, but that's the decimal equivalent. So for instance, just for example, if I had 18%, what would that be in decimal form? I would take off the percent sign, the decimal's right here currently, and I would go 1, 2, and that would be equivalent to 0.18, or just 0.18. Okay, so you take the sign off, move the decimal twice to the left. All right, back to this 5 over 100. So this is a fraction, and yes, it's equivalent to 5%, but it's not in lowest terms. But you guys have learned some divisibility rules, and you know that both of these numbers are divisible by 5, because a number is divisible by 5 if it ends in either 5 or 0. So 5 divided by 5 is going to give me 1 on top. And 100 divided by 5 is going to give me 20 on the bottom. Okay? So, in other words, 5% is the same as 0.05, and that's the same as 1/20th. Okay, so there are our equivalents. Okay, here's our percent, here's our decimal, here's our fraction in lowest terms. Is this fraction equivalent to it? Yes, but it's not in lowest terms, and we like things usually in lowest terms. All right, I bet this probably is number 15, but it's all cut off. During rush hour, Jeffrey counted that he had to stop at 8 different red lights. He went through a total of 25 intersections. What percent of intersections did he stop at? Okay. So, rush hour, Jeffrey counted that he had to stop at 8 out of 25 intersections, because red lights are only at intersections. That's the only point of them. Okay. What percent of the intersections did he stop at? So I can do my ratio like this, but in this situation, it's going to be a little bit more helpful to do it as a fraction. And we are looking ultimately for a percent. So if I am dealing with a fraction, then I want a fraction over 100 because that tells me my percent. So 25 times something is going to give me 100. And so take that same something and multiply the top. So 25 times 4 gives me 100. So 8 times 4 gives me 32. So what percent of the intersections did he stop at? He had to stop at 32% of the intersections. Remember, when we get a number over 100, that tells you the percent, 32%. 230 over 100, that tells you the percent is 230. Okay, 5 over 100, it tells you that the percent is 5, etc. Okay, so 32%. Could I, if I wanted to, could I figure out the number of intersections and the percent of intersections that he didn't have to stop at? And you're like, oh, Miss Goff, don't. But yes, we can. All right. If he stopped at 8, then he didn't stop at the rest of them. So 25 minus 8, 15 minus 8 is 7. Okay, so he didn't have to stop at 17 of the intersections. That is not y'all's bell. Don't get excited. That's just in the background. All right. Could I figure out what percent he did not have to stop at? And yes, you can. You can do it a couple of different ways. You can either say, you know what? He didn't stop at 17 of the 25 intersections. And you can still say, hey, times 4 times 4. And that's going to give you an equivalent fraction that'll tell you your percent. 17 times 4, let's see, 17 times 2 is 34. So that's going to be 68 because that's 17 times 4. Okay, so he didn't have to stop at 68%. But I can also figure that out if I had just said, hey, I know that all of the intersections make up 100%. He had to stop at 32% of the intersections, which leaves 68% that he didn't have to stop at. So a couple different ways you can do it. Anyway, the question that they originally gave you asked for this. Bonus content, woo woo. All right, one more. Number 16. In a home run derby competition, there were 32 home runs hit out of 124 hits. Approximately what percent of hits were home runs? Okay. So on this one, it's going to be a little bit more challenging just simply because we can't easily do a fraction out of 100. So 32 out of 124 were home runs, okay? We can say 32 out of 124, okay? I can say, hey, make this equivalent to a percent fraction. Okay, I can do it that way. These two guys would multiply together, and that would give me 3,200. And then I would have to divide that by 124. Okay, 124 will go into 320. I think only twice. 2 times 4 is 8. 2 times 2 is 4. 2 times 1 is 2. Okay. 10 minus 8 is 2. 11 minus 4 is 7. 2 minus 2 is 0. Okay. And then I can bring this 0 down. 124 will go into 720. Ooh, I'm going to come down here and make sure, but I think it's going to be like 6. 124 times 6. 6 times 4 is 4. 2 times 2 is 12. 30, 40. Nope, just a little bit too much. Okay, so 5. 5 times 4 is 20. 5 times 2 is 10, 11, 12. 5 times, let's see, 5 times 2 is 10, 11, 12. Put down the 2, carry the 1. 5 times 1 is 5, plus 1 is 6. And I get 100 left over. Bring down a 0. I've now hit the decimal, but I haven't gotten a clean no remainder. So 124 will go into 1,000. I think it's going to be like 8 times. 8 times 4 is 32. Put down the 2, carry the 3. 8 times 2 is 16, 17, 18, 19. 8 times 1 is 8, plus 1 is 9. I get 992. 1,000 minus 992. And that's going to give me 8. And I can keep going, but I really don't want to. Okay, and I just said I really don't want to keep going. Well, that makes sense because it says up here approximately what percent of hits were home runs. Well, I could carry down a 0, which I just did, and the 124 won't even go into 0. So I would have to put a 0 and I'd have to keep going, but it does say approximately. So, I mean, if we wanted to round it off, it just depends on how they want you to round. But this would be about 26%, okay? It's a little bit more exact to say 25.8% if you wanted to round it to 1 decimal place, but, you know, something about 26%, okay? Okay, so just to drive home the point, remember it's been a while since y'all have done the, I think they call it butterfly, where you cross multiply these two and then divide by the other number. Let's just do that one more time. Let's say you had 3 colored piece of paper, 3 red pieces of paper out of a total of 40 pieces or something like that, okay? What percent of the papers are red? It doesn't scale up perfectly to 100 if you're looking for the percent. So you can take these 2 guys, and that's 300, and then you divide by 40. Okay, 40 will not go into 30, but 40 will go into 300. 8 times 40 is going to be 320, so 7 times 40 is 280. Bring down a 0. 40 will go into 200 5 times, okay? So in this case, 3 over 40 is equivalent to 7.5%, okay? But I simply did that because it's been a while since y'all have done the cross multiplying, and I wanted to remind you of that skill.